Hello guys and welcome to the process series. So in that tutorial we will basically amplify some from the latest beginner tutorial, so you can watch that, and after the beginner tutorial with the main topic noise you can watch that one here. Currently, just to give a promotion out, CG Circuit currently got sale, so 2 more days, so today and tomorrow, with 30% off. And a new Patreon coming this weekend too, so there will be another exclusive tutorial on my Patreon, so you can join my Patreon if you want and get in touch with me via website, or there are a lot of links up here, so for example to my Instagram account. Okay, without further talk, I think we can get started. Let me just close here my PC cover and we're good to go. So, noise. There are several things we can talk and work about, but I think one of the basic things we can do is to play with some volume advection and take that a little bit further. But I think the first one that I think is pretty cool to do when you first start out with Houdini, and this is of course a process series, so I will explain everything as good as I can. We can start, for example, just with a simple grid. So we will press tab and type grid, GR, and here is the grid. Click on it and you will place down a grid here. I will change the view from smooth shaded to smooth wire shaded, so we can see our polygonal lines here. And what I want to do, I just want to rename that, so press F2 or just press into the name here, and I will just call it Geo RD process. Cool. We'll dive inside. You can dive inside into your geometry context container. You can dive inside there with double click, or you use the I key and dive up with U, or you can dive up here. That's fully up to you. Cool. So we place the grid down here, and one of the first simple things to do is to play with noise, of course. For example, noise attribute noise here. So we'll place it down, connect that, and you can already see we will get something. So currently the noise will be placed on the points and not on the primitive, so you can change that, for example, to primitive, and you will see random colors appearing here. You can change the random colors. For example, you can change the amplitude, you can change the roughness, you can change the octave, so the complexity of the noise, you can change the element size. So for example, when you bump the grid resolution up, we can do that. So go to rows, drag and drop that onto columns, and choose relative channel reference. So we got now a reference to the rows channel, and you will basically get the same number down here. Let's try 50, and now you can see the impact from the element size. So this is like a really big element size, and you can make it smaller and smaller and smaller. And you can play, of course, with the offset. That's pretty cool too. You can click on the little icon here. So this is like overall offset, but you can choose, of course, different axes. So, for example, X, Y, and Z, for example. Let's just reset that here. And you got different operations, of course. Then the attributes names, you can, for example, not do it the color way. Of course, you will get a visualizer, but you can name it, for example, Let's name it just noise. And you will see nothing. But you got an attribute. Let's go to our geometry spreadsheet here. You got an attribute on your primitives that is called noise. And you can even visualize that, of course. So go on the little info button here and then click on noise. And you can see now our noise visualized as an attribute. You can remap or re-ramp the values. You can output the raw value. There's another thing, you can scale the amplitude in different directions. You can introduce some warping. I think that's pretty cool too, with the simple attribute noise function. You can post-process your noise, so you can fit your noise between a given maximum and a given minimum. That's pretty handy too, in my opinion. So you can change that. Another thing is you can disable that, and of course you can use a min-max node. You can download that on my Gumroad. You can introduce an animation on your noise, so that's pretty cool too. So you can do that, for example. And of course the different noise types. So I think that's pretty cool too. You can change them here, for example a Berlin noise. You can get a Manhattan noise, but to visualize them better, let's pipe that up here a little bit, maybe 250. And let's go to smooth shaded, and now you can see them much better. So you can play with them. That's pretty cool too. You can of course do a float noise or a three-dimensional vector noise. I usually use maybe a float noise in the beginning and then build it up a little bit. But I think a float noise is a handy starting point. Let's go for, I don't know, Manhattan cellular. Of course you can change then here your patterns. And I think the cool thing is that you can animate it, so let's play around with that. So first of all, let's just leave it like that, and I'll go back to 50 for example. I think that's enough for now. And the cool thing is, what we can do, for example, we can use this noise. So we now placed our grid. We placed then our noise on top of the grid or on the primitives. So we got an attribute called noise that is sitting on the primitives, and we can use that individual value to control maybe another node, for example. So what we can do now, for example, we can use a poly extrude here, and we can use the noise as an input for the poly extrude. So go on individual elements here, on a primitive, that's fine, local control, distance scale, and we will use the noise. And let's go up, and you can already see we've got here something nice. And what we can do, we can place a VOP between here, or we can use it a primitive, a wrangle, a primitive wrangle. So for example, whoops, we can dive in here. We can bind in, so import an attribute called noise. Type is float, that's already good. And we can multiply that, for example, with a given value. So a parameter, multiply the noise with a given value, and bind. this multiplied attribute out again. And let's just call it again noise. And we will call that mult. And now you can see we can go to primitives. We can control our height or our basically our distance extrusion with this parameter here. Of course you can do that too with a primitive wrangle. You can do f at noise times equals channel float and call that mult, for example. And you now got your multiplier here. So that's basically the same thing. So you can do a little bit of wax or you can use a VOP. That's fully up to you. So now we got our poly extrude, and let's lower that a little bit to maybe 2, I think. Should be fine. And now, of course, we can use the animated noise and have a look. So we will get something like that. Of course you can lower the or pipe up the pulse duration, so the noise will get a little bit slower. Of course you can do like 10 and it will get really subtle and basically slow movement. So I think that's pretty cool too to do. After that we've got of course our little procedural setup, and we can bump up, for example, our rows. And of course you can cache that out and you can render that out, but we will do that later. The cool thing is we've got our attribute noise, and we can place down on null here to generate like an input point. So input geo, pipe that in here, disconnect that, and place down a sphere, for example. Go on polygon, pipe that up. Maybe we need to scale up a little bit our sphere, maybe like 25. And let's have a look on our noise. Okay, that's maybe too big, the element size. So you can pipe it down. You can of course pump it up here. Then you can use a divide node like compute dual to get this hexagonal polygons here, and you will get something like that. So that's like a really simple process, but the cool thing is you can build up that process. We got now, for example, 2 different inputs here. We got the sphere and we got the grid, and let's work with the grid, for example. We've got here our simple extrusions or extruded polygons, and of course they will change over time. For example, what you can do, you can play with the inset, so to make it smaller to the outside. Another cool thing is to play with the twist, but I think you need then some divisions, and maybe you need to get rid of the inset. So you can use a twist to twist them a little bit. I think that's pretty cool too. Another thing we've got now, currently we've got like a sphere. We noised a specific attribute, and with this noisy attribute we will control this poly extrude node here. The cool thing is what we can do, we can go back and dial in like a little bit lower frequency, so something like 10, for example. And we can play with the inset here. So just try out a value that you like. get rid of the divisions here. And then there's, for example, another process. What I really like always to do is a VDB from polygon and mesh that whole thing, for example 0.01. Then go further with a VDB smooth. VDB smooth SDF, let that thing smooth and really go hard with 0 iterations. Nice, maybe maybe 45. And you can basically smooth that whole thing down. Okay, that's maybe too much. Let's try 10, for example. Maybe that's a look you want to achieve. Well, let's go with 15. Something like that, and then you can again convert it back. Cool. And you will get this abstract thing here. The cool thing is you can now cache it out over time, and because we got our animated noise, of course this will take a little bit because of the smoothing process, etc. But you've got basically your animated thing here. Another cool thing to do is when you do that, for example with lines or with advection. I think on the beginner tutorial is a part with particle advection and noise, so you can look that up too. That's pretty funny here. Another thing to do so is with Voronoi. So Voronoi fracture, and we need a thing to fracture. So for example, let's use a sphere here, and I want to introduce to the sphere some frequency, so maybe something like that, and I want to introduce some noise. Let's place down a warp here. Does the point warp create noise? Dive inside, and what we want to do, we want to use the position of our sphere, manipulate the position, and bind or export the manipulated position out to the sphere. It sounds complicated, but it's pretty easy. We'll just need, for example, 2 nodes, an anti-LS noise, for example, and a displace along normal. The position into the position into the displaced along normal position, and the displaced position to the outwards position, so to the exported position, and a noise into the amount. Ta-da! Finished. So pretty easy. Nothing complicated here. And now you can play with these parameters. So for example, I want a really high amplitude, something like that, 5, why not? Dive up, and now we can play with a Voronoi, get a scatter here, and you can basically cut this object into different pieces. I think that's currently 1,000 pieces. I think we don't need so much pieces. Let's go back, and I don't want 1,000, I just want maybe 25 pieces. And we will use the interior surface, that's right. Let's just cut that and visualize that. You can visualize it by piece prefix, and then go here on this little visualizer icon. And now what I want to do, I want to basically there are now again just like with Houdini every time. There are several ways to achieve something you want to do. And what I want to do, I want to separate these individual fractured pieces and then maybe get them a little bit together again with some connected adjacent pieces and some remeshing like glue or something like that. And we can do that several ways. For example, a really simple way would be exploded view. Piece attribute will not be name. Oh, it will be name. Yeah, sure. And you will get something like that. So we can do something like that. But I want to get like fewer pieces, like maybe 5, or let's. Yeah, I think an odd number will be good. And I will disable the relaxed iterations here. Something like that should work. So you can use that, for example, or you can use a for each loop. Whoops, not that for each loop, the for each connected piece. And with this for each connected piece, you can place down a transform. And I got a preset here, but it's pretty simple. We will just need to place down a transform. Not that one. A transform node here. And what we will type in the pivot transform, pivot translate. So here we'll type in centroid, open brackets, close brackets, and then 0, 0, and then just copy that, 0, 1, and 0, 2. And what this will does, it will place the pivot into the center of the current iteration geometry. And the cool thing is, now you can scale each individual here. Let me just visualize it better with more pieces. You can scale each individual piece on the center, for example, something like that. So you can use that, of course, too. Let's go back to maybe 7 pieces and get rid of the random global seed, or of the given global seed. 0.75. That should work fine. And the cool thing is, we got a loop. Now we can iterate between each individual piece. For example, let's grab a piece here, remesh the whole piece. We can of course smooth it out a little bit, play with it, get the noise from top here, from the top, get it in here, but I want the amplitude much lower here, and I want to fit that a little bit. I want to fit it between from minus 0.5 to 0.5, between 0.125 and maybe 0.75. And then I want to visualize the noise first, so pipe that out to CD, disable that one here, and we will need a normal here. And we will need a higher frequency. Yeah, that should work fine. And a smaller scale, so you can play a little bit with the scale here. And you can do that then of course for each piece here. And you can play with the noise, so you cannot use an anti-aliased noise, for example. You can use a unified noise. I think a unified noise will be pretty good. Unified noise static, It's all about noise. And let's have a look, maybe get some rocky look. We'll not use the fit now. You can use it, of course. Just pipe that into a mount, that into here, that from here. Maybe that cellular look and get it a little bit wider, so spread out a little bit the element size to get larger pieces. Maybe a periodic and a hybrid terrain to get a little bit finer noise introduced in here. Of course you can play with the resolution, but it's fully up to you. That should work fine now. Let's have a look on each piece here. Yeah, that looks pretty good. And now what you can do, you can mesh the whole thing together, for example. Or we can mask that out. We can use inner pieces. For example, we've got here our interior group here. What we can do here, that's like now a brute force thing. We will get the inside group. We will use this group for mask from geometry as a reference geometry, and it will take a little bit of time, but what we will do, we'll create like these inner masks. And you can play with that, for example. And you blur it out. So I will blur out not the position, I want to blur out the mask here on a proximity blur. Scatter some points on there. On the mask, that looks good. Connect adjacent pieces. So let's play with the connect adjacent pieces. So if you are satisfied with that part, you can, for example, use some noise and displace the whole thing, or you can merge it back with your original geometry and then merge that, of course, together. There are several ways to do that, I think. For example, you can use a resample on VDB, because I think a polywire would be too heavy. A VDB from particles, and of course increase the scale here. Decrease the scale, sorry. And then you can copy basically the whole thing from up here. But we need some more nodes. We need a VDB combine. We need another VDB from polygons. Of course you will lose some detail, but you can of course also increase the resolution. For example, an SDF union. Smooth the whole thing out. Let's have a look on 15. Oh, that looks interesting. Yeah, nice. Let's disable the point. Oh, that looks cool. And the cool thing is, you can use that thing again here to create noise. And I'll create some noise on top, but let's use the other one here, this one here. And what I want to do, get that here and go down with the amplitude, but I want to increase the frequency to get a little bit of surface detail. Something like that. Go lower with the scale here to just get some detail. Because you can increase that, or you can decrease it to get a smoother look. Another thing what you can do, you've got that thing here, and we can use again a mask, so mask from geometry. We will convert that back to polygons here, and we will use that as a mask. So now we can, for example, lower the radius here, place a null node. Well, let's just lower the radius a little bit more, because we can blur it again. That will be mask again. And we can use that mask for shading. And of course you can introduce some noise here again. Cool. Let's place down a final null here. Out geo rs redshift dive up. Place down a material network and a rod network. RS mat and RS out. Let's place a redshift node here, RS out 001. I will enable some things here, maybe brute force. That one, that one, that one, that one. And on RS material builder, RS mat. Let's call it test. Got quite a little tree here. That's good. That's good. That's good. And we need a material. node, just connect it RS mat. You can press Shift W, go to your RS mat, so basically your material network, and drag and drop it in here. So the shader is now applied. We will need a RS dome. Oops, no, 0, 1. Let's go with no, whoops. Okay, let's go with lights. I will choose an HDRI file. Just a pretty simple one, like a studio lighting setup. Camera 1. We need a camera. Camera 1 already set up. Good. And then we basically can start to render that thing out. Let's start the Redshift render view. So, camera P3, that should be fine for now. We can, for example, disable or enable the background. That's fully up to you. Maybe you like it dark, or you can set up, of course, a background manually. I will just disable it for now, and I will disable that in viewport to get a little bit better framing here. I will get a little bit higher rendering resolution and just a higher focal length or a longer focal length, and I will enable I will not disable, I will enable here the DOF, the depth of field, and I will use a bokeh image. Bokeh image. That one here. Copy and paste that one here. Save the file. Let's just enable autosave here. And enable the render view. Now, of course, we can bump up the COC radius if you want to. You can frame it in an interesting way, maybe. There are really several interesting perspectives on that mesh. No, not 21, 2. And now we can dive inside here, and we got one attribute that is sitting on the points, and we can use that for shading. So call user data, and I think we called it mask. Just pipe it to the surface and refresh your render view. Yes, that's the right one. So we can use an RS material blender and create two materials, for example. One material that is a little bit more rough, and one material that is, for example, copper and a little bit more shiny. Throw this into base color. This into layer color 1, base color, and blend color. And now you can see we already got a successful blending happen here. And now you can of course play with the color. Whatever you like. That's of course fully up to you again. But I think you can get some nice perspectives out of that one here. Okay, cool. So I think you will get some nice style frames out of that abstract thing. I hope you liked it. So we played with noise, we played with some VDB stuff, masking and so on. I think some close-up will look pretty dope too, with some heavy depth of field or some more cinerama or anamorphic aspect ratios, maybe a medium format ratio like 6:6 or something like that, or 6:7. So you can of course experiment with that, with basically everything. And if you got some style frames or you want to show me something, post it on Twitter, Instagram, etc. Mark me or just send it to me and I will have a look. And I hope you liked it, and I will see you in the next tutorial. So have a great day and take care and learn Houdini. Bye.